So that,
Yeah, that would be good. The other ones are.
actually. I was nothing like the practice does.
Okay. I was, so I had no conceptual question, and I'm really bad at those. So I was like. Now I'm worried. I'm going over right now. Yes, and then the problems came like, this much just about the interval. Yeah.
Maybe like a really person, you give you the full image, it's homework, and it's grafted, animation plus again.
Yes, yeah. No, I'm worried about that final. That's the problem. Right? Which made me so mad when it's supposed to be like on the whole year, but they didn't jump on that last one.
And I can see why they don't say. That's all you need.
I was on it.
I'm wondering, like,
I don't know how the first two things, pretty helpful, right? Yeah, my one.
I thought they were all weighted the same. I thought they were all 20 points or 20% of a 15% being homework, and the other 5% quiz grades, 14%. Homework quiz. I think the finals weighted the same. Why don't we get the extra bonus points in the practice? If you got all those, it'll be, yeah.
Yeah, compare the bonus.
Oh, it's 82%. No, I guess not. I think it's like 20.
That is that.
I thought it was just like, it's amazing.
I didn't notice it.
Like 20.5.
In the email.
Either.
The last question was.
Yeah, it's like 20.5.
The only one was
I
really.
think the fine is probably 2%.
I get something.
Yes, it's fine for some questions. Or you could do it something like where it's like if it's 30, you can do like 15, 15, 15, then. I was gonna have.
Yes.
Or yeah, maybe it is like that. Maybe it's 15, 15, 15, and then the final's 35% of our grade. Could be.
I've seen it.
Yeah, it's not like a bio tells us that the finals weighted exactly. Oh, given that this everything was about the syllabus, like. Yeah, no, I think that. First comes the worst, I guess 7 millions. Might be a B minus. Really should just take it ourselves today. There's also always only like a smart mostly like. Really? I think next semester I'll start taking earlier. Just get them out of the day. Just go about my day. So it's just them. I guess a lot of people.
Okay. All the friends for it. It is.
I'll get to like this. Yeah, it's like a little tail. I did it yesterday. Okay, so let's get started. Today is actually the last two lectures for this semester, right? And what we're going to do today is actually to go through the things that we should actually know for your final
But before we get into those details, this is kind of like the announcement. Make sure you actually submit your final course evaluation by the end of this week. I will update your extra point during the weekend. Okay, so by next week you see all your extra points be updated on the Cengage. Okay. So any questions before we get started? So if not, then okay. So couple things. I guess I post a final review hangout. So those are questions I actually received from the students, and then I found it's actually thought was some time to actually discuss them and using as a review material for the finals. Okay. So the very last four is actually for the midterm 3. So I feel like probably actually this is actually the things that I should actually finish first. Okay, so last week we actually went through all these important equations and concepts that you should know for the midterm 3. Okay, so chapter 16 to chapter 18, right? So 16 talking about the delta G, right? So 3 equations that you actually memorize. Okay, so let me write those equations down. So the first equation is delta G is actually related to the delta H and delta S through this specific equation, okay? And then delta G naught, okay, can be related to your equilibrium constant K through the second equation. And the third equation is the delta G can relate to your delta G naught and your chemical quotient Q, right? So these are the 3 most important equations for chapter 16. Okay, and then in chapter 17, then we start to talk about the E naught cell, right? So the delta G naught can be related to a delta E naught cell using negative n times the value constant times your E naught cell. And then your E naught cell can be related to your K using 1 over n times 0.025693 times your natural log K. And then the E cell can be related to your E naught cell minus 1 over n times 0.025693 times your natural log Q. Okay, so these are how the E cell or E naught cell relate to your free energy and equilibrium constant K or the chemical quotient Q, right? For the electroplating, the only things that we learn is actually the math, the grade of the product can be calculated using the current times second divided by number of electron got transferred divided by the value constant times the formula weight or the molar mass of your product. Okay, so that's pretty much the things that you should know for the chapter 17. Okay, equation wise. Okay, chapter 18. I guess the most important equation is actually you need to know the nuclear equation, right? So if you have atomic symbol XAZ, okay, it becomes SBU plus ECV. Then we know A is going to equals to B plus C. Z is going to equals to U plus B. Okay. And then the other thing that's important is actually to know how to predict the decays, right? So in order to do that, you need to actually know the N to Z ratio, and then also know the threshold, right? So you need to actually memorize that table. Yes. A times S. Yeah, A multiply the time in second. Yeah, so all the things actually the things that you need to actually memorize. Okay. So in chapter 18, the other important thing is actually to know the 4 particle, right? The alpha, beta, gamma, and the positron, right? So all these particles need to know what it means. Calculation the decays. Okay, only one equation, natural log AT over A0 equals to negative K times T. And then the mass defect, okay, the delta E equals to delta M times C squared. Okay, so those are the important equations for 6, 7, and 18. Okay. So by now you should actually be very familiar with lab because you guys just have the return 3 this week, right? All right, so let's go through a few examples that I feel like I didn't actually went through it very. Yes. Okay, all the things we can actually get it on Teams, right? Yeah. Mm-hmm. Delta G naught.
So does G naught is equal to negative N as itself, and then does G naught is equal to negative RT that's one then.
Yeah, so it's actually equivalent. So you can write all the things together, that's fine. Okay, so this is what you mean, right? So if you do this, it's actually how you derive the second equation. Yeah. Because the temperature is at standard condition is actually a constant, right? So the Barry constant is actually a constant. Okay, if you put those constant, they give you this number 0.025693. Okay, so we sort of go through these things in the lecture on the YouTube videos. Okay, this is actually how we get to the second equation.
So when I
About the question that is sent to me.
yeah.
Yeah, so this is my reply. I actually contact the point is actually all correct. The answer is actually also correct. Okay, but somehow the system they did not set the range properly.
Okay.
That's why I found your answer wrong. But I let the camp manager know, so he already revised it. Yeah, so. Okay, so those are the things that we should know. Okay, and the example I want to go through. Somehow it become very blurred now. Okay, now it's okay. Okay, so this question is here is actually small, but hopefully you can see it. For a reaction, Fe2O3 plus 3H2O give you 2Fe plus 3H2O. The delta G naught is 53 kilojoules at 25 degrees C. Delta H naught is 100 kilojoule. Which of the following is completely true about the relationship between your delta G and T for the reaction? Okay, so the first, if you read these questions, okay, it actually, again, most of question actually can break into multiple parts, right? This is actually the first part. It gives you an equation. It gives you delta G naught. It gives you temperature. It gives you delta H naught. Okay, so let me write these things out. Okay, the things that you have is so in our. Okay, we can actually come back to here. You'll see all the things. There's actually only one equation for chapter 16. Contain the delta G, delta H, and the T, which is actually the first equation, right? So what I'm trying to tell you is actually, I give you delta G naught, delta H naught, give you T. I want to calculate what the delta S naught is, right? This is actually what I'm trying to tell you. Okay, so just do it. Okay, so delta G naught is 53 kilojoules, right? Multiply 1,000 is going to equals to delta H naught is 100 kilojoules, so times 1,000. Okay, minus T. T is 25 degrees C, right? So 298 K times your delta S naught. Okay, So apparently through this relationship, you can actually calculate what the delta S naught is, right? So you know that delta S naught is going to equals to okay, so it's 157.7 joules per mole per K. Okay, so this is actually the first thing that you can get. Okay, once you get these numbers, a few things you want to actually pay attention to. One is actually the quantity, okay, 157.7. Two is actually the sign. Okay, so it is a positive value. Okay, so that's actually something that you should actually know. Okay, so it is actually positive 157.7 joules. Okay, then if you're trying to read the description here, so we can see in all description, it's talking about two things. One is temperature, one is actually delta G, right? So pretty much it says, okay, if temperature above certain degrees K, and then the delta will be positive or negative, right? So how do you actually make the judgment of this? The first thing is actually to know under what conditions that your delta G is going to equal to 0, right? So if you, okay, once your delta G equals to 0, okay, then you can actually figure out at what temperature you can actually have the conditions, right? Since you know your delta H is 100 kilojoules, right? You want to figure out the temperature in Kelvin, okay? Right now you know your delta S is 157.7, okay? So by doing this calculation, you know when the temperature is equals to 637 K, then you're going to have your delta G equals to 0, okay? So now you can look into this term. Okay, so if temperature is 637 K, the second term, because your delta S naught is positive, right? The higher the temperature, your second term will become more negative, right? So if the second term become more negative, then your delta G will become negative. Okay. Then you start to actually fit into all the description here, right? When the temperature larger than 3, okay, it should be 365. When the temperature is actually larger than 365, then you know your delta G will start to become negative, right? So the first description will be actually the correct description. Okay, all the others just the you put in those contexts you want to give those delta G. Okay, so this is actually how you figure out the proper description to describe the relationship between your delta G and the temperature. Okay, so the first thing is actually first you need to figure out what the delta S naught is. Okay, and then figure out what temperature your delta G is going to equal to 0. Okay, then based on the sign of your delta S, then you can actually predict the relationship between your delta G and the temperature. All right, so pretty much conceptual problems. Okay. The second questions. So this is actually more related to chapter 17. Okay. So here it says consider a galvanic cell. Okay, so keyword galvanic cell. Every time we see this keyword galvanic cell, then the things that we should know is that the inner cell has to be positive. Then typically you're going to see two half reactions, right? And for both half reactions, they are actually all reduction reaction. Okay. That means actually to actually flip one of them, and after you adding up, your inner cell has to be positive, right? In order to achieve that, the only possibility is actually you can flip the first one, right? So you should have 2 chromium 3 plus 7H2O. That give you Cr2O72 minus plus 14 protons plus 6 electrons. Okay, so this will give you the E naught oxidation, which is going to equals to negative 1.2 volt. Okay, so your E cell or E naught cell will simply equals to the sum of this and this, right? So it will be 1.75 minus 1.2. That give you a final voltage of 0.55 volt. Okay, so this is actually your E naught cell, right? And then you want to calculate your delta G naught, okay? And if you check out our equation again, delta G naught is related to your E naught cell through this simple equation, okay? Therefore, we know that delta G naught can be calculated through negative N times your Faraday constant times your E naught cell, okay? So E naught cell we know is 0.55. Faraday constant was actually provided right here, okay? 96485. Now you need to actually figure out what the N is, okay? So if you check out your oxidation reaction or your LoRa, okay, here it gives out 6 electrons, right? And then for your G-Rock, it actually update 2. Okay, so in order to get a balanced redox reaction, all you do is actually multiply 3 for your G-Rock and you're adding up, okay? But overall, you will know that the number of electrons that got transferred between the two half reactions will be 6, right? Therefore, you know it will be 6 times 96485 times 0.55. Okay, and this will give you a value of negative 318,400, which is negative 318 kilojoules. Okay, and this is actually how you get to this specific answer. Okay, so that's actually questions that you need to know what galvanic cell is, right? And you need to know which half reaction you actually believe before adding all up. Okay. Okay, the next questions that's relevant to midterm 3 is more conceptual questions. Okay, so consider the following system at equilibrium at 25 degrees C, where PCl3 plus CO2 that give you PCl5, for which delta G naught is negative 92.5 kilojoule. Okay, what will happen to the ratio of partial pressure of PCl5 to the partial pressure of CO2 as the temperature rises? Okay, so temperature rises. Okay, so every time you see this temperature changes, okay, and then you see this term delta G, okay, 99% of time, you want to actually know the sign of your delta S. Okay, because that means actually the second thing is going to play some role here. Okay, so you have delta G now, right? You have temperature. Okay, so okay, means actually you need to know the sign of your delta S. Okay. So in order to do that, first you need to know this equation again. Based on the equation, can you predict your delta S is positive or negative? Is it positive or negative? How many gas molecules you have for your reactant? 2, right? How many for your product? 1, right? So the delta S will be positive or negative? Negative, right? Because always product minus the reactant, right? So you know your delta S will be negative, right? So if you are, so now you know your delta S. Delta S is negative, right? Temperature is always positive. That means the second term minus T delta S will always be positive, right? So if you make the temperature very high, that means actually your second term will dominate. Okay, so what will it? It will actually make your delta G become positive, right? Okay, so if delta G is become positive, what does it mean? Okay, so let me write it out so everybody can follow along. Okay, so delta S is negative. Okay, at high temperature, negative delta S is positive and dominates, right? Therefore, your delta G will become positive. Okay, so if delta G is positive, means actually moving from the reactant to the product side is not a spontaneous process, right? But you can also translate that into then the reaction from the product to the reactant will become spontaneous, right? Means you're going to have more reactant to form. Okay, so okay, so those are the constants that you should know. And here it asks you what will happen to the ratio between your PCl5 to Cl2, right? So they want to know this pressure of your PCl5 over the pressure of your CO2. PCl5 is your product, right? Cl2 is actually your reactant. Since right now you want to put you will produce more reactant, therefore the ratio between these two will decrease, right? So you know this is going to decrease, right? And that's actually the answer that you should choose. Okay, so recap. So this question first give you a reaction, okay? And then it give you delta G, and then it give you the temperature, right? So from the equation, you should be able to figure out the sign of your delta S. Okay, and then you will know based on that, the second term, okay, if you go to high temperature, okay, or low temperature, you can actually predict what was going to happen to your delta G. Once you know the sign of your delta G, then you will know it's going to move to the reactant side or the product side, right? And then after you know all those relationships, then you can actually start to check out the things that cares about, right? The ratio between two quantities. Okay, then you can actually predict the quantity will actually increase or decrease accordingly. Okay, so this is actually the more conceptual questions that sometimes like, students will get confused. All right. The very last one question that's related to midterm 3 is this one. Okay, so this question asks you that, okay, Pb210 decay to produce the Hg2O6 with a half-life of certain time, okay? Start with the sample of 7.5 gram of Pb. How many gram of mercury will be present after 17.5 years? Okay. So there are two sentences in this question, okay? And the first sentence is always trying to, if it tells the half-life of certain species is certain time. Okay, by now you should know that this is trying to tell you what the K is, right? Because the equation we're going to use is that natural log AT over A0 equals to negative K times T, okay? Half-life means your AT simply equals to half of your A0. Therefore, on the left-hand side will be simply equals to natural log 1/2. On the right-hand side is negative K. The time is 22.3 years. Okay, so you can actually calculate your K, and you should be able to get a value of 0.031. Okay, so per year. Okay, so that's actually your K. Okay, so once you know your K, then you can actually move to the second part of the sentence, right? It says, if today you have 7.5 gram of PB210, right? You want to know how many Hg2O6 you are going to have. So all the equation that we learned is actually only focused on the species that you originally have. Okay, in this case, it's actually you only have PB, right? So if you use the equation that we have, you can actually calculate the AT of PB. Initial one have 7.5 gram, right? Negative K is 0.031 after 17.5 years. Okay, so you can actually compute your AT. Okay, so your AT will equals to 7.5 times exponential negative 0.031 times 17.5. Okay, so once you do that, you should be able to get a value of 4.35 gram. Okay, that means after 17.5 years, you still have 4.35 gram of what species? You still have 4.35 gram of your PB210, right? So that's how much of PB still remain. Okay, so that means actually you have 7.5 minus 4.35 gram of PB got consumed. Okay, so this will equal to 3.15 gram of PB210 got consumed. Okay, so what happened to this PB is that your PB210 will becoming Hg206, right? So in order to compute the mass of your Hg, what you need to do is actually you first need to compute how many moles of PB that you have consumed, which will be 3.15 gram divided by 210. Okay, so that's how many mole of PB will be converted into your Hg, right? And then to calculate the mass of your Hg, then you actually multiply the molar mass of your Hg. Okay, so once you do that calculation, then you know you are going to get 3.09 gram of Hg206, and this will be your final answer. Okay, so many students actually miss this very last step. So you will answer 3.15 instead of 3.09. Okay, but this is actually the very last concept I feel like I should cover for the midterm 3. Okay, so any questions for this? Okay, so if not, then let's jump back to your midterm 1 and midterm 2. Okay. Because the question we cover is actually limited. Okay, so today we only cover the overall, I guess it's only like 20 questions, right? But that's probably actually not enough. Okay, so how should you actually prepare your final is that I would strongly suggest that everybody have like 1-page summary of each chapter, right? Go through those things first. Okay, and every chapter we have, I don't know, 10 to 15 questions, right? Go through those things. Okay. You have done your midterm 1, midterm 2, midterm 3. Practice midterm 1, practice midterm 2, practice midterm 3, right? Go through those questions. All right. So, and after doing all these questions, you are pretty much all set, I think. Okay, so those are the things that you want to know. Okay, so don't get panicked, but do come back and revisit those concepts and questions. Okay, make sure you don't make calculation errors. Okay, then I think you will be fine. Right. All right, so what we're going to do today is actually we're just going to do a few questions that I found interesting. Then I want you to actually also understand before you do your final exam, right? Okay, so first thing first, let's go back to the midterm 1. So midterm 1, we have 3 chapters, chapter 10, chapter 11, chapter 12. In chapter 10, what we do is we start to learn all the kind of definition of the concentrations, right? The molarity, mole fraction, mass percent, molality. Okay, so you should know, by now you should actually know all those definitions, okay? And then a very important concept in chapter 10 is that we tell you the delta H of solution is composed of delta H solvent, delta H solute, plus delta H mixing. Okay, delta H solvent and delta H solute means the energy to actually put in to break apart the solvent molecule and solute molecule. Typically is positive. Okay, and delta H mixing is typically negative. Okay, and the delta H solvent and solute, we have a special name called the lattice energy, right? So you should actually know those things. Okay. And then the very last part of the chapter 10 is actually we start to talk about the collective property. Okay, so you should know how to actually compute the vapor pressure of a solution. Okay, and then the temperature, the boiling point elevation, freezing point depression, and the osmotic pressure, all those things you should actually memorize it. Okay. So those are the things that you should know. Okay. Do you want me to actually write out all those equations for you guys now? Yeah. Okay, so go back and check out those things. All right. And then chapter 11 is actually we start to learn about the rate, right? The kinetics. Okay. So you should actually know what is actually the disappearance rate of a species or appearance rate of a species and how it's like related to the overall reaction rate. Okay. I guess that's actually a bit too much. Okay, let's just write out this simple one. Okay. AA plus BB, they give you CC plus DD. Okay, so the overall reaction rate can be defined as negative Okay, so the R here is actually the overall reaction rate, right? The A dt or delta A over delta T is the disappearance rate of A. Okay, and it related to the overall rate through this equation. You actually divide it by the coefficient in front of it. Okay, so again, the overall reaction rate can be related to the disappearance rate of B. Okay, you can actually put in this -1 over B so that you can actually make it equal to each other. Delta C, delta T is actually the formation rate of C. Okay, this is the formation rate of D. Okay, then all these rates can be related to your overall reaction rate. Okay, this is actually some important concept that you should know. Okay, and then in these chapters, we also actually learn this integrated rate law. Okay, and then we learn about the zeroth order, first order, and second order, right? So for the zeroth order, okay, the equation that you should know is actually the concentration of A at time t can be written as negative KT plus A0, okay? If it's actually a first order, then it's natural log AT equals to negative KT plus natural log A0. Second order will be 1 over AT is equals to positive KT plus 1 over A0. Okay, so these are the 3 different orders, right? And this equation is especially useful when you see pictures, right? So if you see a linear relationship between, let's say, AT versus time, okay? So if the y-axis is AT, your x-axis is actually t, and you see a negative slope, then you know that's actually a zeroth order reaction, okay? But if you actually apply out the natural log AT versus time, it shows this linear relationship, then you know it's actually first order. Okay, for the second order, if you see it plot out 1 over AT versus time, okay, then it's second order. Okay, so this actually where this equation is actually powerful. Another important thing for chapter 12 is that typically they give you a different concentration of your reactants and give you a final rate, right? So you can write out your rate law to figure out what's actual order of the reaction for your differential rate laws. All right, and then the other very important equation for chapter 11 is that you need to know how the rate constant K. Okay, so these actually equations that you should actually know. Okay, how the rate constant K is related to the activation energy of EA, right? So this is actually some equation that you should actually memorize. And then openly, if you go back and check out the question, you'll see the question actually bring out two different rate constant, okay, and two different temperature. And the equation you should use is natural log K1 over K2 is equals to EA over R 1 over T2 minus 1 over T1. Okay, so this is actually another key equation you should actually memorize for chapter 11. Okay. All right, so that's pretty much all the things that you should know for chapter 11. Okay. For chapter 12. Okay, chapter 12, we start to talk about the equilibrium constant K and the chemical quotient Q. Okay, so of course you need to know how those things was defined, right? So the Q can be defined as, if we still use this AA plus BB give you CC plus DD, right? So chemical quotient is equals to C to the C's power times D to the D's power over A to the A's power, B to the B's power. Okay. You can write your chemical quotient Q at any given time. Okay, but once they reach equilibrium, the Q is going to become your K. So those are the things that you should know. And then if you have reactions, okay, let's say the equation that we have an equilibrium constant K1. Okay, so if today you flip that reaction, meaning if you do this, then the new equilibrium constant will becoming the original one, but you have to take the reciprocal of that. Okay, so once you flip the reactions, you take the negative 1 power of the original rate constant, original equilibrium constant. Okay, if you multiply a constant to the overall reaction, then the new equilibrium constant will equals to negative m power, right? So if you multiply of your equation at the equilibrium constant levels, it always change at the exponent. Okay, so those are the things that you should know. Okay, the very last important thing for the chapter 12 is actually the Le Chatelet principle. Okay, so here basically you want to know how only three things will affect the equilibrium constant. Okay, one is actually concentration, second is actually pressure, and third one is actually temperature. Okay, how these three things will affect the equilibrium of your equation. Okay, and in this type of questions, you will always see a trap, right? It's always going to put the things catalyst inside the multiple choice, right? So catalyst doesn't change the equilibrium position. Okay, the catalyst will only change the activation energy. Okay, so those are the concepts that you should know. Okay, so that's pretty much all the things all the important concepts that you should know for midterm 1. Okay. Okay, so we're going to use those concepts to do the questions. I guess about 4 to 5 questions, I guess. All right, first thing first. Any questions so far? Okay, so I would strongly encourage you actually just go back and see those, how we actually do those questions one by one, okay? So it says the LaCl3, okay, is going to dissolve and produce La3 plus and 3Cl minus. What is the boiling point of the solution when this much of the solute, okay, that's actually its molecular weight, is dissolved in that much of the H2O. Okay, so this is actually a very standard electric property, right? It's actually about the boiling point elevation. Okay, so the equations that we're going to use is actually delta T, the change in your boiling point is going to equal to I times your Kb times your M in molality. Okay, so here it tells you the Kb is 0.512, right? So this one is 0.512. So this one is actually known. Molality is simply the moles of your solute divided by the mass of your solvent in kilogram. Okay, the mole will be 0.2453 divided by the formula weight, 245.3. Okay, so this gives you the mole of your solute. The mass of your solvent is actually your H2O, right? 10 gram, you want to convert it into kilograms, so you multiply 10 to the negative 3. Okay, then you actually solve the molality. Okay, now you want to actually make sure you input the correct I, right? So what is your I? You need to actually decide from the equations, right? So here you can see one solute is going to give you 1 La3 plus and 3 Cl minus, right? Therefore, your I is going to equals to 1 plus 3, which is actually 4. Okay, so here you actually put 4. After you do like calculations, you should be able to get a value of 0.2048. Okay, so that means actually the temperature will actually increase by 0.2048 degree. Okay, but it's actually asking the boiling point, right? So the boiling point will be the boiling point of your solvent. In this case, is your water, which is 100, right? Then plus 0.2048. That give you the final answer, 100.2048. Okay, so that will be actually the final boiling point. Yes.
Determining ramp-off, do we only use like the aqueous solutions? Is it kind of like how we don't use solids for,
Yes. Okay, so typically the things you see is actually electrolyte. Okay, so electrolyte is going to dissociate.
Yes.
Okay, so once it dissociates, it will present in the aqueous form. Okay. But this is actually the things that you probably will need to go back and make yourself familiar with the how to actually calculate the I properly. Okay. All right, so let's actually how you solve this type of questions. Okay, the second one is a very standard questions that about this concentration conversion. Okay, so previous we didn't actually bring out all the definition here, but I guess by solving this one, we'll give you some idea, okay? So it says calculate the molarity of an aqueous solution that is 22.3%, okay, mass percent calcium chloride, okay? And then it tells you the density of the solution is actually 1.2 gram per mil. Okay, so that's actually a lot of information, right? So when you encounter this type of questions, you want to actually first write out the definition of different concentration terms. Okay, so apparently the target one is the molarity, right? So molarity, you need to know the moles of your solute, right? Over the volume of your solution in liters. So those are the information that you will need. Okay. But the things that you should start with, okay, based on the questions, actually, you start with the mass percent, right? So to know the mass percent, the definition of mass percent is actually the mass of your solute divided by the mass sum of your solute and the solvent. Okay, and then it tells you is 22.3%, right? So if mass percentage are the things that you should start with, right? You can actually make some assumptions, right? In our previous hangout, we say, okay, let's say assume the overall solution is 100 gram. Okay. Therefore, you know your solute will have 22.3 gram. Your solvent will have 77.7 gram. Okay, so this is actually the first step. Okay, because you start from the mass percent, then the assumption we're going to make is actually will assume the overall solution has 100 grams. Okay, so starting from here, since right now you get the mass of your solute, then you can actually calculate the mole of your solute. Okay, the way you calculate is actually by dividing this 22.3 by its molar mass. Okay, so the molar mass of CaCO2 is 100.98 gram per mole. Okay, so what you do is actually doing this divided by 110.98. Okay, so then you can get the moles of your solute. Then you will be able to actually get this information, right? The only thing that you don't have, but you still need it, is actually the volume of your solution. Okay, to calculate the volume of solution, you need to actually start from here. Okay, because we know the density of a solution is defined by the mass of the solution over the volume of your solution, right? Therefore, you can actually compute the volume of your solution like this. Okay, the mass of your solution divided by the density. The mass of your solution in this case is 100 gram, right? So you know this will be 100. Density is actually 1.2. Okay, by doing that, you are going to have 83.3 mil. Okay, so let's actually the volume. Okay, once you got these two information, then you can calculate your molarity, which is this term, so your denominator. This term is actually your, this term is actually your numerator. This term is actually your denominator. But things need to be in liters, right? This one need to actually divide by 1,000. And if you do that calculations, you will be able to get a value of 2.41. Okay, so these type of questions, you're going to see two different concentration units. Okay, so starting from the one that you want to know, list out the definition. Okay, and then move on to the one that you have all the values, make the proper presumptions. Okay, and then solve for the information step by step. Okay, it should be actually quite straightforward. Okay, but this is actually how you solve this type of question. Okay, next one. This one is actually more about the reaction mechanism. Okay, so typically it's going to give you a lot of elementary steps. Okay, the way you solve this type of question is actually you first adding all up. Okay, and then figure out what is actually your reactant, what is actually your product. what is actually your intermediate, and what is actually your catalyst. Okay, so those are the things that you should know, right? So here it proposed 3 different elementary steps and then give you a bunch of choice, actually which one is actually the possible red law for this reaction, okay? So the first step is actually to add and go up so that you will know what is the actual reaction, okay? So if you add and go up, you know this one, the X will be canceled out, right? So X, this one will be canceled. Y and Y will be canceled, right? So in the end, what you're going to have is actually A plus B plus C that give you D, right? So this is actually a net equation, okay? So from the net equation, you know your reactant is A, B, C. Your product is D, right? So what is your X and Y? X and Y is your intermediate, okay? If I actually add in one more, okay? A, B, C, D, let's put an E here. Okay, so if let's actually things that you have, okay, what is E? E will be your catalyst, okay, because E first appear on the reactant side, right? That means actually it is not something got produced, it was originally already there. Therefore, E will be your catalyst. Okay, so just something that I think you should actually know. Okay, so once you know all this information, okay, in order to write out the red law, okay, the red law can only be expressed using your reactant, right? So you know your reactant is actually A, B, and C, right? By simply know this concept, you know this cannot be your answer because C is not, because X is not your reactant, right? D is not your reactant. Okay, so you already cross out 2. Okay, so then the next step is actually you find out the slowest step, right? The rate limiting step. So from the rate limiting step, you know you can just write out the rate is going to equal to rate constant K times the reactant, right? So the reactant is actually A to the first power, B to the first power, right? Once you write it down, then you start to check, okay, does this red law only contain your reactant? If it does, then you're done, right? This will be actually your red law already. Okay, so in this case, yes, it is indeed. A and B is actually indeed your reactants, right? So this will be actually your answer. Therefore, you just select it as your final answer. Okay, so sometimes it won't be this. Okay, you probably actually need to use some other equivalent constant relationship to substitute those things. So that in the end, your red law was expressed using only the reactants. Okay. All right, but always use the slow step, which is actually a random step to write out your red laws first. Okay, so those are the concepts that you should know for these specific questions. Okay, another very conceptual questions. Okay, here you can see the x-axis is actually typically labeled as the reaction coordinate. Y-axis is actually your energy, right? A is actually your reactant. E is actually your product. Okay. How about C? Intermediate, right? How about B and D? Yeah, transition states typically. Okay. So if you actually compare the energy of your reactant and product, okay, so here you can see the product is actually lower in energy, right? And then when you calculate your delta H, okay, it's always the product minus your reactant. Okay, so in this case, you have a negative delta H, right? So if you got a negative delta H, it is a exothermic reaction. Okay. So the energy of your E minus the energy of your A, this is, if it is positive, is so-called the endothermic. If it's actually negative, it is exothermic. Okay. And then there are two, so C is intermediate. B and D is transition states. Okay. So where is actually your activation energy? If I want to actually label the activation energy on this plot, where is it? Okay. Okay, that is actually your EA. Okay, the highest point relative to your reactant, not to the product. Okay, to your reactant. So that is actually your EA. Okay, all those details you need to know. Okay, so this one single figure actually serves the process. Okay, so once you know this, right? How many transition states that you have will label how many steps this reaction is going to have. Okay, so in this case, it will be a two-step reaction. Okay, and then it is a exothermic reaction. Okay, so two-step exothermic are the description of these figures. Okay, and use those information to select out the correct description. All right. Any question for this? Okay, no? Good. Okay, so this one is actually testing how well you understand the definition of the formation rate of a species or the disappearing rate of a species, how they actually relate to the overall rate. Okay, so this question says that the composition of dinitrogen pentoxide is described by these specific reactions. Okay, if the rate of disappearance of N2O5 is equals to 1.4 mole per minute, okay, you want to ask you what is the rate of appearance of NO2 at that moment. Okay, so the first thing is actually to know what it really describes, right? So the disappearing rate of N2O5, meaning is delta N2O5 delta T equals to 1.4, right? And then it want you to actually tells you the rate of delta NO2 delta T equals to one number. Okay, so this is actually what it means. Okay, and the things you should do is actually all the things are actually interconnected to the overall reaction rate, right? So you want to know how those things is related to overall reaction rate. We know the overall reaction rate will be defined as okay, so this is actually how you actually tie everything together, right? The overall reaction rate is actually can be described by negative 1/2 of the disappearing rate of N2O5, right? Delta N2O5 delta T. It can be also expressed as delta 1/4 of delta NO2 delta T, or simply delta O2 delta T. Okay, so these are the relationship. And then you know this term is 1.4, right? Therefore, you know your rate is actually equals to negative 1/2 times 1.4, which is 0.7, right? This thing is going to equals to 1/4 of delta NO2 delta T. Okay, So this is actually the things that the question is actually asking for, right? So all you need to do is actually you multiply 4 on both sides. Therefore, you know delta NO2, delta T was simply equals to 0.7 times 4, which is actually 2.8. Okay. You can also compute the formation rate of your O2, okay, which is going to equal to just the rate, right? Which is going to equal to 0.7. All right. So here is actually the question testing how well you understand. Okay, every time we said disappearance rate of one species or the formation rate of certain species, how are these species, how are this rate is related to the overall reaction rate. Okay, so once you know one, you can actually know all the others as well. Okay. So this is actually a question for chapter 11. Okay, so that's pretty much the things that I want to cover for the midterm one. Any questions? Okay, now come back to the most important part of this semester, I guess. So midterm 2. Okay, so for midterm 2, basically all the things we care about is to calculate the pH of a solution, right? So let's actually review some of the things that you should know before it goes into all those calculations. First thing first, okay? So the conjugated acid base, okay, the difference between your acid and base was simply H plus, right? So okay, if I ask you what is the conjugated acid of A minus, okay, what you need to do is actually put H plus into the A minus, so you're going to get HA, right? What if I ask you the conjugated base of HA? You'll just minus the H plus. Okay, they give you A minus, right? So that's actually the things that you should know. And after that, then you should know the 7 strong acids. Okay, so which including HI, HBr, HClO4, HCl, HClO3, H2SO4, HNO3. Right? So only 7 strong acids, all the others that can be test. Okay. Strong base. Okay. 1A, 2A, oxide or hydroxide, right? So those are the things that we have learned in midterm 2. Okay. After that, we start to actually learn how to calculate the pH of aqueous solution. Okay, for aqueous solution, we know Ka times Kb equals your Kw equals 10 to the negative 14. pH plus pOH of aqueous solution is also equals to 14. pH is defined as negative log of proton concentration. pOH is equals to negative log of OH minus concentration, right? So those are the very fundamental questions, fundamental concepts that we should know, okay? And after that, then if you have a strong acid, then to calculate the proton concentration, we know it was simply equal to the strong acid concentration. For strong base, then the hydroxide concentration was simply equal to the strong base concentration, okay? Weak acid, proton concentration can be calculated using the square root of weak acid concentration times your Ka. Weak base OH minus concentration equals to the square root of OH minus concentration times your Kb. Very last one, buffer. HH equation. pH equals to pKa negative log weak acid over its conjugate base, right? Okay. And then the very last things that you should know is the percent dissociation, which is actually the proton concentration over the acid concentration, right? That's actually the percent dissociation. Okay. Yeah, I think that's actually pretty much all the equation that you need to actually memorize. Okay. All right, so these are the quick summary about the things that we should actually know. Get back to here. Now from the simple conceptual questions. Given the following pKa value, which is the strongest acid? Okay. So pKa. Okay, so Ka is actually describing how easily that your substance is going to produce a proton, right? The larger the Ka, the stronger the acid, right? However, here it do not give you Ka. Instead, it gives you pKa, right? So pKa is negative log of your Ka. Because of that negative sign, right? You should actually looking for the smaller pKa will be the stronger acid. Okay. So in this question, it give you actually a bunch of acids and then a bunch of pKa. Okay, so then you start to actually check out the pKa values, and you realize that this guy is actually the one with the smallest pKa, right? So that one will be your strongest acid. Okay. The weakest one will be which one? This one will be the weakest one, right? Yeah. So important concept here is actually pKa is that if you have smaller pKa, you have a stronger acid. Okay. It's totally opposite to the Ka value. Okay, so make sure that you know if the questions actually give you the Ka values, okay, you want to looking for the one with the largest Ka value for the strongest acid. Yes. Yes. So larger the Kb, stronger the base, right? Smaller the pKb, stronger the base. Okay. All right. So second questions. What is the OH minus in a solution that have pH of 12.8? Okay. So you know the pH is actually a negative log of H plus, right? So, but you're computing OH minus, that's not so convenient. Okay. So what I would suggest is that going from here, because we know pH plus POH equals to 14, right? Since your pH is actually 12.8, therefore you know your POH is going to equal to 14 minus your pH, which is 14 minus 12.8, they give you 1.2. Okay, so POH give you 1.2, right? And then we also know that POH is simply negative log of OH minus. Okay, therefore you take the exponential on both sides. Therefore you can calculate your OH minus concentration is equals to exponential negative 1.2. And then once you do like simple calculations, you will get a value of 6.3 times 10 to the negative 2. Okay, and that's actually how you find out this answer. Okay, so it's pretty much just a definition type question. 10 to the, oh, no, you're right. Going too fast. Thank you. Okay. Yeah, be careful though. I'm not the one who is going to push all those buttons, right? Okay, so this is actually how you do these questions, okay? Next one. Calculate pH of 0.3 m solution of formic acid for which the Ka value is actually 1.8 times 10 to the negative 4. Okay, so first figure out what is actually a solution you're going to have, right? Formic acid. It's not one of the 7 strong acid. It's a weak acid, right? So weak acid. Therefore, you know the proton concentration can be calculated using the square root of weak acid concentration 0.3 times Ka 1.8 times 10 to the negative 4. Okay. Once you do the calculations, you should get a value of 0.00734. So pH is simply equals to negative log 0.00734. That will give you a value of 2.13. Okay, so very straightforward. But key is actually to know what solution that you have. Okay. Next question. Okay, calculate pH of 0.4 m of sodium acetate given the Ka of acetic acid is 1.8 times 10 to the negative 5. Okay, so again, you need to know what solution that you have, right? So what kind of solution do you have? Basic salt. Okay, how do you know? Okay, I still feel like this actual part is the student struggle the most, right? So later I actually realized actually a tip that I want to share with you. Okay, so first thing actually focus on the things that you have. Okay, this actually NaCH3OO is actually things that you have, right? And then you're going to see a Ka value of another species, right? CH3COOH. Okay, are they the same? They are not, right? So if they are not the same, that means actually what? It gives you a Ka of an acid, right? The species highlight here will be a weak acid, right? But the things that's given here is not a weak acid. But they look similar, right? The only possibility is actually the things that given inside this question is its conjugated base. Okay, so let you know, this must be a conjugated base of that weak acid. Therefore, you know you have a weak base solution. Okay, so all the things that you need to actually pay attention to is that is this guy exactly the same as the one that provides Ka? If it is not, the species that's given here must be the conjugated partner of the given one. Okay, so here it gives you a weak acid. Therefore, you know you have a weak base solution. All right? Does that make sense? Okay, that will actually make your life a lot easier because most of students have problems actually you don't know what kind of solution that you have, right? So really pay close attention to it. Okay, if they are not the same, okay, if they give you the Ka, which means if they give you a weak acid, okay, that means actually the question that you have, the real solution that you have will be a weak base. Okay, so the same thing will apply if they give you a Kb of certain species, but the question that the species that you have in your question is not exactly the same of that, then you're going to have a weak acid solution. For example, if today I give you this, and then I say the Kb of NH3 is certain value. Okay, so here you can see I give you NH3, right? I give you Kb. That means NH3 must be a weak base, right? But in your question, the things that you have is like NH4Cl, right? Then the NH4Cl has to be the conjugated acid of the weak base. Therefore, you're going to have a weak acid solution. Okay, So pay close attention to the chemicals that was given inside the question to the one that provide the Ka or Kp values. Then you will know what solution that you have. Okay. Does that make sense? Okay, because I feel like it's very difficult to let everybody see what solution that you have. Okay. But by simply comparing the two, I hope this actually provide another way to let you figure out what kind of solution that you have. Okay, so get back to here. Since inside these questions, the Ka was provided, okay? And you also notice that the species that was actually you have from the solution is not exactly the same as lactic acid. Therefore, you know it's actually a conjugated base. Therefore, you're going to have a weak base solution, right? Since you have a weak base solution, you can calculate the OH minus concentration using the weak base concentration 0.4 times Kb, right? But here, you only have Ka, right? So you need to actually use the Kb is equal to Kw over your Ka. Okay, Kw is actually 10 to the negative 14. Ka is 1.8 times 10 to the negative 5. Therefore, your Kb will equals to 5.56 times 10 to the negative 10. Okay, so you need to actually use this value, plug in here. Okay, so once you do like calculations, you will be able to get a value of 1.49 times 10 to the negative 5. Therefore, you can calculate your POH equals to negative log of 1.49 times 10 to the negative 5. Therefore, you get a value of 4.83. So 4.83 is actually your POH, right? So your pH is simply equal to 14 minus your POH, which is 14 minus 4.83. That's going to give you a value of 9.17. Okay, that's how you should get to this answer. Okay, but I hope this example give a better way to actually identify what kind of solution that you have. All right. Any questions? Okay, I think I'm running out of time. Okay, so I will stop here and then we will continue all the remaining questions on Thursday. Okay, thank you.